Unit 12 Test Review Pre-AP. Okay, so on the first ones, we're just writing equivalent expressions for each. So this was that whole crack and bottom thing. So basically, the number on the crack will go onto the bottom of the rational exponent. So for the first one, you would get a 6, and then 4 over 5. Again, that's that crack, and that's that bottom, okay? The next one here, you would have a 2. There's nothing you can really do with that 2. And then you would have x and to the power of 3/4. On the next one, the way you'd want to change this one is you want to do the square root. Now remember, there's really a 2 here, and there's really a 1 here. So that would give you 4, that would actually give you 4 over 81 to the power of 1/2. And then you would have x, and then 9 over, to the power of 9 over 2. Now, this would actually end up being 2/9. Now, if you were going to keep this as a rational exponent, you would just keep it like that, okay? All right, on the next one, you need to multiply these because that's the rule for exponents when you have a power to a power. And then this 3 would also come over here because there's really a 1 right there. So what I really have here is I have the cube root of 3 and then x to the 15th, okay? And then if I were to actually write that in rational, making that equivalent expression, so rational form, that would be 3 to the 1/3, because the 1/3 is always a cube root, x 15 over 3, and then that would reduce to, if I were to keep it as a rational exponent, I would keep it like this. Okay, on the next one, again, that 5 over 2 goes to both of these, so it would have 4, and then 5 over 2, and then x 5 over 2. Again, if I'm going to write it as a rational form, those exponents, I would just keep it like this. All right, the next one, again, there's nothing you can do with that 64. It just has an exponent of 1. So 64. But then this one you would want to put here. This would go on the crack, because it's on the bottom, and right there. All right, the next one, again, you'd have the radical with an x. The q is on the bottom. And there it goes. All right, this one here, again, the x has a 1, so x, and then the 3 would go here, and then squared. Okay, on the next one, I am doing, we're going to simplify these. So I have a 5th root, but I'm going to take care of all this first. So what I really have in here is I have 1 over 32, x to the 20th, okay? Now, I'm going to find out what the 5th root of that would be. Not there though. Alright, so math, and then I'm going to come over here, put a 5, and then in here I'm going to do 1 divided by 32, and I get this, which is nice because that's a perfect, that's like 1/2, okay, so that's good. Alright, so I'm going to have 1/2, and then this is my group, so I'm going to make groups of 5 out of 20, and that gives me 4 of them. So x to the 4th. All right, on the next one, I'm doing a square root. So I'm going to find out what the square root of 16 is. I'm sure most of you already know, but I'm doing this for a reason. All right, and that gives me a nice little 4. So that tells me I don't have to do a tree or anything, because sometimes you'll have to break a number down into that prime factorization tree. So this is a 4. Now, this is a 2. We've never put it for a square root, but it's always been there. All right, so now what I'm going to do is I'm going to start making groups of 2 of all this, and I'm going to kind of just make a little line here because that's going to tell me where everything goes. All right, I can make one group of 2 out of this, so there's one group, and there'd be 1 left over. I can make 4 groups of 2 out of that, so y to the 4th, and I can make 2 groups of those 2 to get the 4, so there. So that would actually be your final answer. All right, on this one here, you need to start from the inside, outside. So the first thing, inside to go to outside. So the first thing you want to do is you want to do this, okay? So here, I would have 27 to the power of 1/4, and then 1/4 times 12 is 3, so x to the 3rd. Now, I'm going to find out what 27 to the power of 1/4 is, because it may be a nice number, so I'm just going to kind of see. And if it isn't, I'm going to deal with that 1/4 later. So that's not a nice number, so I'm just going to leave it like that. All right, now I'm going to deal with the 4/3. And again, you multiply because you got a power to a power. So here I would end up with 27, and that would give me 4 to the 12th. which would reduce. And then I'm going to do x, and then that gives me 4. Okay, so I'm going to find out what 27 to the power of 4/12 is, or 27 to the power of 1/3. And I know 1/3 is a cube root, but I'll do this without simplifying that, but understand that that is 1/3. And there you have it, 3. So the final answer would be 3 times x to the 4th power. All right, the next one, I'm going to take this piece by piece. This will go here, this will go here. So on this one, I would have x, and that gives me 16/3. And then I would have a y, and then 24. Okay, because I'm just multiplying. Power to a power, you multiply. All right, now I'm going to come over here, boom, boom. I've got x, and I've got a y, because 1/5 times 5 is just 1. All right, so now what I have to do is I need to add, because I got to combine these. Now this one's easy. I got a 24 here and a 1 here, so that's 25. So y to the power of 25. But there's a 1 here. So I'm going to do 16/3 plus 1 right there. And I get that. I'm going to change it into a fraction. So that's 19/3. So x to the power of 19/3 times y to the power of 25. All right, flipping it over. Okay, on this side here, we are solving them. So for this one, I wanted to always think about the inverse. So the inverse of a square root is a square. So I'm going to square this. And whatever I do on one side, I do to the other. So I'm going to square it. So now I've got x plus 12 equals x squared. Now, it's a quadratic, so I need to make it equal 0. So I'm going to subtract each side. Okay, and these all cancel out. Okay, so what I now have is, I have x squared minus x minus 12 equals 0. All right, so now I'm going to factor it. So what two numbers multiply to get negative 12 and combine to get negative 1? It's going to be a 4 and a 3. And I need to have more negatives. All right, so x equals 4 and x equals negative 3. All right, so now what I'm going to do is I'm going to make sure I don't have any extraneous solutions. So here I'm going to do x plus 12. Down here I'm going to have an x. I'm going to go to my table. All right, so when I go to x is negative 3, you'll notice that these two numbers are different. So that means that this is my extraneous. Okay? That's my extraneous. So that's going to be no solution. And then I'm going to double check with the 4. So go down to where x is 4. There it is. Both of those are the same numbers. So that's my solution. All right, on the next one I'm doing a cube root. So you get rid of a cube root by doing a cube. So I'm going to cube this side. Whatever I do on one side, I do to the other. So now I have 6 minus 2x equals negative 8. And then I'm just going to start solving. So minus 6, negative 2x equals negative 14. Divide by negative 2. Divide by negative 2. X equals 7. And again, like every single question that you can do on this test, you can check it. So I'm going to do the cube root of 6 minus 2x, and then I'm going to come down here, type in negative 2. If I go to my table, we said x equals 7, and you look at that, the y1, y2 are the same, so that is my answer. All right, on the next one, you have square roots on both sides, so I'm going to square both sides. Okay, and whatever I do on one side, I do to the other. Okay, so I have 8x plus 3 equals x plus 17. I'm going to subtract the x. That gives me 7x plus 3 equals 17. And really all at this point, you're back to solving just two-step equations. I mean, at this point, that should be very basic. So x equals 2. And again, you can always check your answers. All right, on the next ones, we are solving equations with rational exponents. And you're just going to solve these like you normally do. You want to get the x by itself. So you're going to add 5 to both sides. That gives you x to the power of 2/3 equals 25. And then at this point, you want to get rid of the rational exponent. So you raise the whole thing to the power of 3/2. So I just flipped it. And then whatever I do on one side, I do on the other. So 25 to the power of 3/2. And if I do 25 to the power of 3 over 2 in my calculator, that is not 25, that's 12. So 25 to the power of 3 over 2, and you get 125. So x equals 125. All right, so for the next ones, again, y'all, it's the exact same thing. Okay, so on this one, I'm just going to divide by 5. So divide by 5, divide by 5. That gives you x to the power of 3 over 2 equals 8. And then I just flip it again. I'm going to raise it to the power 2/3. Whatever you do on one side, do the other. So if I do 8 to the power of 2/3, I get 4. So x equals 4. And again, you can check these in your calculator. Just put them into y1, y2. All right, the next one, you need to get rid of that whole parenthesis. That's to the power of 3 over 2. So I'm going to do 2/3. Again, I just flip it. Whatever you do on one side, you do the other. So what I have here is I have 1/2 x plus 1 equals, and then if I do 64 to the power of 2/3, I get 16. And then I'm just going to start solving it like a regular equation. And x will equal 30. All right, the next one. Again, this is really kind of like a one-step equation, except that you have the rational, so it becomes like a two-step. So I'm going to add 6. That gives me x to the power of 3 over 2 equals 8. I'm going to put that whole thing to the power of 2/3. Whatever I do on one side, do the other. And again, if you do 8 to the power of 2/3, which is actually the same thing that we have over here, you get x equals 4. All right, the next one are the word problems. You will have some of these on the test. So this one says the time it takes for a pendulum to make a complete swing back and forth is given by the formula t equals 4 pi times the square root of L divided by 64, where L is the length. Okay, so that's important to know your variables. And a clockmaker wants to build a pendulum that takes 10 seconds. So that's probably going to be the T for time to swing back and forth. How long should the pendulum be? All right, so I'm going to start putting in my variables. So 10 equals 4 pi times, I'm finding out what that L is, over 64. Okay, so the first thing I have to do is I have to get this radical by itself. So I need to divide this whole thing by 4 pi. And whatever I do on one side, I do on the other. So now I have 10 divided by 4 pi equals the square root of L divided by 64. All right, so I need to square this to get rid of that square root. I'm not going to mess with this yet, y'all. I'll deal with it in a moment, not right now. Okay, so that leaves me with that equaling L over 64, because the radical's now gone. Now I'm going to multiply the 64, okay, and I'm going to multiply the 64 by this. So now the length will equal 10 divided by 4 pi squared times 64. Okay, so I'm going to put that in my calculator. All right, so I've got 10. Actually, let me put that in parentheses. I've got 10 divided by 4 pi times 64. Oh, I forgot to square it. And you get about 40.5. So the length in feet should be about 40.5 feet. All right, on the next one it says the equation V equals the square root of 81h. Approximate the velocity, so right there, of a roller coaster car in feet per second at the bottom of a hill h feet high. If the car travels at a velocity of 30 feet per second at the bottom of the hill, how high is the hill? And I'm going to round to the nearest tenth. Okay, so they tell me the velocity. So 30 equals the square root of 81 times the height. I'm going to get rid of the square root by squaring both sides. Then I'm going to divide by 81. Okay, and if I do 900 divided by 81, I get 11.11. So the height is approximately 11.1 because they wanted us to round it to the tenth. Okay, all right, the last one, a scale that classifies wind speed and can be modeled by the function. Function BW equals 2.8 times W plus 6 minus 7.8, where H is the speed of the wind in miles per hour. If the function BW equals 12, what is the wind speed W? So what is this in miles per hour? All right, so I know what it equals. So 12 equals 2.8 times the square root of W plus 6 minus 7.8. All right, so I'm going to add the 7.8 first. And that gives me 19.8 equals 2.8 times the square root of W plus 6. And I'm going to divide this. Okay, and then when I divide that, I get that. So you know what I'm going to do? I'm going to actually leave this how it is right now because that is such a yucky decimal. So I'm going to leave that as like a fraction. All right, so now what I have is I have 19.8 over 2.8 equals the square root of W plus 6. All right, so to get rid of that square root, I got to square both sides. Again, I'm not going to mess with this yet. So that gives me 19.8 over 2.8 squared equals W plus 6, and then minus 6 minus 6. Okay, so I'm going to put that whole thing in my calculator. So 19.8, I don't think the 1 hit, 19.8, and then 2.8 squared minus 6, and the wind speed is 44 miles per hour. So the wind speed is approximately 44 miles per hour. And again, I hope this helps you. If you have any questions, make sure you ask your teacher. And the test is Tuesday and Wednesday. All right, thank you very much.